Let's take a look at more examples on remainder theorem. Now, we have already learned about what remainder theorem is. Remainder theorem simply states that if Px is any polynomial of degree 1 or greater, and if A is any real number, then if we divide the polynomial Px by x minus a, the linear polynomial x minus a, then the remainder of this division is simply the value of the polynomial at x equals a. So if we find out the value of polynomial at x equals a, this gives us the remainder of this actual division. This is what the remainder theorem tells us, right? Now, what about instead of dividing the polynomial px, instead of dividing by x minus a, what if we divide the polynomial px by x plus a? What will be the remainder? So in this case, we know that the remainder will be simply equal to the value of the polynomial at a, right? So what will be the remainder? Can we find out the remainder if the denominator or the divisible polynomial is of this form? And it's actually very, very easy to answer. All we do is that we, instead of writing it as x plus a, we write this as x minus a. So if we write it in this fashion, then this becomes in the same format as this, right? In that case, we can tell that the remainder now will be value of the polynomial at minus a. Because if we have it in this form, right, then all we have to do is we have to find out the value of the polynomial at this value. So typically, in this case, this is a. And if it were plus, we can write it in this fashion. So in this case, this is actually minus a. So this will be minus a. So if we are given a question where the denominator is of the form x plus a, we simply find out the remainder by finding out the value of the polynomial at p of minus a. So let's take a look at some examples. So let's say our first example is, let's start out with some maybe one or two linear polynomial. So let's say we want to divide 5x plus 8. We want to divide this polynomial by the polynomial x plus 1. So what is the remainder? So remainder will be quite simply, we will write x plus 1 as x minus 1, and we want to find out the value of the polynomial at minus 1 now. So if we do that, so we have 5 minus 1 plus 8, or this will be minus 5 plus 8, or 8 minus 5, which will be simply 3. So let's do this division and see indeed if the remainder is 3. So we divide this by x plus 1. So 5x by x is simply 5. And then we have 5x plus 5. Then we subtract. So this cancel out. 8 minus 5 is 3. And indeed, the remainder theorem is saying that the remainder should be 3. And when we do the long division, we see indeed the remainder is 3. Let's take a look at one more example. This time, let's say our px is equal to, let's say, 2x squared minus 5x plus 3. So we have taken a quadratic polynomial, and let's say we want to divide this by x plus 2. And we want to find out what is the remainder. So the remainder theorem, so we will actually write this as gx as x minus 2. So the remainder theorem is saying now if we simply find out the value of polynomial at minus 2, that should give us the remainder. So let's find out what that value will be. So we will write this like this, and then we have here minus 5 minus 2 plus 3, or this will be simply, so minus 2 times minus 2 is plus 4, so that times 2 will be 8, and minus 5 minus 2 is plus 10, and then we have plus 3. So this will be 18 plus 3, 21. So let's see if we do this division, indeed, are we getting the remainder as 21? So let's do our long division here. So it will be 2x squared minus 5x plus 3 over here. And we want to do the long division. Our divisor is this. So the first term will be 2x. So we write 2x squared. 2x times 2 will be 4x. So we get this. We subtract. So this goes away. We get minus 9x. So we divide minus 9x by x. We get minus 9 over here. Oh, we forgot to get the plus 3 here. So minus 9. So this will be minus 9x. And this will be minus 18. Minus 18. And when we subtract the signs, they reverse. So this cancel out. So 3 plus 18 will be 21. Indeed, we saw the remainder theorem giving us the remainder as 21, which is what we get when we do the long division. Let's take a look at maybe one more example. Actually, this is an example that we had seen earlier when we did the long division, right? But this time, instead of having it with x, dividing this polynomial px by x minus 4, let's try to find out x plus 4 and see what happens. So when we actually, this time, let's do the long division first. So if you do the long division here, so let's do it over here. So we have x cubed plus 2x squared plus 3x plus 5. So this is our polynomial, and we want to divide this by x plus 4. So the first term will be, we take this, divide by this, so it will be x squared as our first term. So we get x cubed plus 4x squared, right? We subtract it, so this cancels out. So 2x squared minus 4x squared, so minus 2x squared. Then we get these two terms over here. And now we divide minus 2x squared by x, so then we get minus 2x. So we multiply minus 2x by this, we get minus 2x squared. And minus 2 times this will be minus 8x. Minus 8x. When we subtract, so this signs, they change. So now we have 11x plus 5. We divide 11x by x, get plus 11. So we get 11x. And we get 44, plus 44. Okay. We subtract, so they cancel out. So 44 minus 44 plus 5. So I think that'll be minus 39, I guess, right? So minus 44 plus 5, I think it is minus 39. Now let's find out the remainder using the remainder theorem. So because it is x plus 4, we want to find out the value of the polynomial at minus 4. This is what we are trying to find out, right? This will give us the remainder. So we have x cube over here. So we have minus 4 cube, right? Plus 2 minus 4 square plus 3 times minus 4 plus 5. So minus 4 cube will be minus 4 times minus 4 times minus 4. So it will be minus 64. Minus 4 times minus 4 is plus 16. This will be plus 32. This will be minus 12 plus 5. Or we have, let's consolidate the negative terms. So this, if we add these two, we will get minus 76, I believe, yeah. And if we add these two, we will get plus 37. So we have 76 minus 37. So we will get 39 minus 39. Minus 39. Which is exactly the same as what remainder we get when we do the long division. So this is how we use remainder theorem when our polynomial that we divide by is of the form x plus a.